Good evening, everyone. I'm happy to start the introduction of our data science work at Caru. Before presenting the project, we would like to introduce ourselves. My name is Guillaume Azarias, and I have a background in research in neuroscience.
My name is Jun Shebi. I'm a marketing and sales data analyst with background in consumer study.
My name is Christophe Bousquet, and I did my PhD in animal behavior in Zurich, and I am interested by the interface between the individual and the social level. So Jiyun, Guillaume, and I did our final project at the Propulsion Academy with Caru, a company that aims at connecting residents and caregivers, and also their families. One of their motto is being close to grandma and grandpa. So how does Caru provide this service? Well, Caru offers their client a device that is represented here on the table. And this device comes with 5 sensors, all located inside the device. One sensor recognizes voice commands and connects directly resident to a person of trust via a phone call when the resident says "Hilfe" or "help." The other 4 sensors track light, CO2, temperature, and relative humidity. And all of these variables can be linked to human activity. For instance, when we breathe, we produce CO2, or when we switch on the light at night, we usually do not sleep, and so on. So here is an example of a CO2 change within the day. The x-axis is from midnight to midnight, and as can be seen, CO2 level is quite consistent until 3 a.m., which means the resident was sleeping. From 7 a.m., it picks up because activity started, so by checking CO2 change, we could understand activity levels. So from Caru, we received 4 streams of time series, 1 per variable, and we implemented machine learning algorithm to cluster activities and detect anomalies. The link between recorded variables and human activity only allow to detect general activity pattern and therefore respect individual privacy. The end of our project is to help providing new services like better allocation of caregiver time and prompt support to residents when needed. With this, I give the floor to Jiyun, who will present the methods we used.
Thank you, Christophe. So to cluster activities and detect anomalies, we approach it with 3 different methods. First method is within-day clustering. Through pre-processing and k-means clustering, we capture change dynamic, and we also distinguish sudden or smooth change. We also calculated daily activity index by integrating change frequency of clusters and pervasive CO2 level. You can see 2 days example here. On 13th of January, CO2 was rapidly changing and it was very colorful, which means clusters were changing over time within that day. On this day, activity level was very high. On 21st of December, however, CO2 was persistent on the lower level and the change frequency of clusters was quite low. This could mean no one was at home. As no surprise, activity index recorded 23 out of 100. Second method is between-day clustering. Let's say each line in the left side of the graph represents each day of one resident. Dynamic time warping allows to stretch portions of time series to find a better match between different patterns. As can be seen in the right side of the graph, we separated days per similar daily pattern. One with a high peak in the middle of the day, and the other one with 2 peaks within the day. Last method is activity detection. To determine unusual activity, we customize a strategy based on time series forecasting developed by Facebook. We took advantage of the continuous recording of CO2 from Caru's sensor to model the activity pattern of residents. The model is then optimized and used to predict how the activity pattern of today should be. The predicted pattern from the model is shown in blue in the graph. By comparing the predicted results with the latest measurements, we detected how often and when a resident had an unusual activity. Unusual activity here is detected in red in the graph. Now Guillaume will present how the methods are integrated in our dashboard.
Thank you, June. So we have integrated our analysis tools within a dashboard that is dedicated to be used by caregivers and family members. So something that goes to the point and that can be read easily. So first it shows a summary, very big summary of the data analysis to check at a glance if a resident exhibited a normal activity within the last 24 hours. In this case, we can see that the predicted activity in blue match the real measurement. So most likely this woman is fine. But then if I switch to Daniel and observe his activity, we can see that the real value in black are way outside of the predicted value. And we can observe a lot of peaks, which means that during the night, this person had a lot of activity. So the caregiver has to check these people. Then we can confirm this analysis by other methods, the between day clustering and the within day clustering results. So how is grandma doing today? Nowadays, people live far away from their family and they need more medical help as they get older. To keep the connection with elderly people, Caru provides a convenient way to establish a phone communication between elderly people and family or caregiver. And to bring even more safety to elderly people, Caru uses smart sensors that collect environmental change that can be translated into human activity. We have worked with Caru's data to identify activity patterns and detect abnormal activity. Our work was dedicated to alert the relevant people when the elderly people might need help. We worked a lot for this project and hope that this result will be integrated as a product by Caru, and we are waiting for the answer in the next few weeks. So we are grateful towards Francisca Damayer from Caru, who was helping us for the project, and our mentor at the Propulsion Academy. You're welcome to ask questions if you want. Thank you.